Alright, this is our setup for our flow control device. How it works is we have a function generator here that has a sine wave that actually does a square wave, a triangle wave, and a sine wave. You can actually change how the amplitude, the voltage going into it, and the frequency based on how you have it set up. What we have here is an amplifier module connected to a speaker and a power strip that controls everything else that we have hooked up to it. This actually amplifies the signal from the function generator and produces a more amplified signal, which you know the speaker works off of just voltage. We actually have a fan with a flow control device that actually controls the amount of flow coming in to the system and comes out the tube on that side. As it travels through this tube here, it comes to this box. This box is made up of just water, like 3 inches of water, and a mister fogger that actually oscillates the ceramic disc, creating the fog. As it comes up here, we actually have a nozzle that has got a 1.5 inch diameter hole in it, and it actually shows up. We actually have this laser here if you want to get that. We have a green 200 milliwatt laser shining through a cylindrical lens that spreads the beam out, and it actually goes across this plexiglass into the flow. Jen, if you want to get the flow here. As the flow comes out, let me get over here. As the flow comes out, you can actually see these little vortices coming up. We're actually trying to figure out what type of function actually gets this to work the best, and which we found out today. We're actually going to use a straw number, which has got to do with the diameter of the nozzle, the velocity coming out, and the frequency that we're using it at. Supposedly, the best account for vortex flow is a straw number between 0.2 and 0.4. We still got to do more research on this. What we have here is a high-speed digital camera. It can do, about 10 megapixels? And it's got very, very few corrections that have to be made in the system. This can take a picture, about 5,000 pictures within 25 to 30 seconds. Alright, but what we're trying to do here is we're actually trying to create these vortices and use the laser, which we have here. We have a mirror, it's not here right now, but it actually fans through this flow here, and eventually it's going to get sent to this computer over here, which will use the computer to actually use a program called MATLAB, which is a computer programming software that it will actually take those images we take here and it will scan them on a 3D axis, and it will actually create a 3D image so we can actually see what's going on in this flow at any second in time after we get it done. We still have plenty of work to do, but you can actually see here we're actually going through different types of frequencies and pitches. Sounds like a car. But we actually have it set up to do, we can get it down to as much as 1 hertz. But we're still playing with it, trying to figure out what exactly is going to work the best. So far, we've got it set up to where we can use the laser and get images in just one plane. Eventually, we'll get the mirror back and we'll scan all 3. But eventually, we're going to start doing research. But that's pretty much what we have set up now. We're actually still modifying somewhat, so it'll be better later on.